Okay, well, hello everyone and welcome. My name is Dalia and I'm part of the community team of Elastic. Welcome to today's meetup where we're going to hear from Okan about how we deal with system faults in critical healthcare system. And we are a small group today, but that gives us an opportunity to have a discussion and a lively chat, hopefully. So yeah, I'm gonna give the floor to Okan now, and let's take all of the questions at the end. Go ahead.
Hello everyone. As Dalia said, we can keep it interactive in this presentation and demo. I had already performed this presentation in community conference as a lightning version, but I will have to go into the details in this one. Let me first refresh your memories if you already participated, or if you didn't, let me tell you what this work is about. I work in Turkcell, and I have been working in Turkcell for about 13 years. I have about 16 years experience. And Turkcell is a telecom operator in Turkey, and it also has investments in other sectors too, like electronic cars, IoT, blockchain. I personally am a blockchain expert also. And also, Turkcell also has investments in hospital information system software. And actually, in this specific scenario, Turkcell purchased the code in code of hospital information system, and it was a very hard code. It is a huge monolith, and it had very problems, and we also had come together to solve those problems in hospital information system. And as it sounds, it really is critical. One of the first bugs I fixed was that the system could not give prescription to cancer patients. It has a different feeling to fix those bugs. So to cut to the chase, and actually there were so much endpoints, there were so much problems. We had to mine those data, and we had to see what we had to escalate those problems to the right team. They're looking at the hospital information system. It looks like this. There are 6 different development teams. They all do developments related to each other. As you can see, all modules are hugely dependent on each other, and each color represents a different team in this scenario. So in this case, how do you know if a problem occurs in which product, in which module, and how do you escalate them? How do you prioritize those issues? And how do you even solve the performance issues? How can you know about them? It's a huge monolith. There were countless app servers, more than 100 external dependencies, REST and SOAP external services. There were huge bottlenecks, and as I said, it was the critical questions was to prioritization and escalation. And you probably are all aware of this topology, and we all had made a MetricBeat, FileBeat, and UpBeat bundle, and put them into our application servers, and we fed our LogStash and ElasticSearch using that. And some of the problems we had was to parse those access log URLs, and there were very different URLs with dynamic parameters. So we had to just eliminate those dynamic parts and simplify the URL, and so we can see a URL pattern, performance pattern. So in the this is what we saw, but I will also show you the production environments in a minute and production data. And as you can see, we were able to see the peaks in the performance, and we also had able to see were able to see which servers had problems. So as in the top graph, you can see the all endpoints average performance. In the bottom one, you can it's a heartbeat request. Yeah, it is a dummy request. But if it was WebLogic we were using, it didn't support Spring Boot or any lighter, even lighter than any framework, even lighter than Spring Boot. So we had, as you can see, there were some peaks in this scenario, and if any one of those blue and red peaks meant that there was something wrong with this server. And we also injected and logged SQL codes, so we were able to see which SQLs resulted in most delays. And when it comes to the later problems, actually ElasticSearch, Kibana, or any other alert mechanism does not directly give you the pattern info, but ElasticSearch has so many good functions you can use to show the pattern. So you can write your own requests to see if request shows the anomaly. So if in this scenario, we actually the performance of the endpoints can change depending on the day, and it doesn't. For some endpoints, it is not critical to have a slow performance in the night. But for some endpoints, for some days of the week, you can see a slow performance, and it is acceptable in the hospital scenario. But you need to compare the time performance of the duration of the request with the same time of the days with other with past week, past month, etc. So this code you see in GitHub has an parametric anomaly analyzing algorithm inside, and it brings it shows the anomalies, and it sends an email, and you can see that in a threshold of 2 seconds, in a spike rate of 200%, etc., etc. These your endpoints have problems. So this was the request that I sent. Actually, I aggregated the endpoint performance by URL and also took the average of duration. And actually, there were so much endpoints, I had to use minimum document count of 5. So because there were some limits in Elasticsearch regarding that, and in the left part I collect the current performance, and in the right part I collect the past performance, and I compare it with a simple arithmetic calculation and see if there is an anomaly. And also, when it comes to the exceptions, LogStash was a huge help. It was difficult to implement for me because I am not a good regex expert, but It took me a while to do that, but LogStash has full opportunities here, and we were able to extract the valuable Oracle exception data, Java exception data. We were able to replace dynamic contents in here, and also we had reached the stack trace. Actually, this is the same output that we see when an alarm comes. So it is easy to see for a developer to where is the fix, where is the problem, what do I need to do. And we had also used the stack trace information to escalate it to the right team. So that was something I also already told in the Elastic conference. So I want to show you about the what it looks like. So first I will show you the production environment, and I will try to show you a different case with the in my developed environment. So this is we created a performance dashboard, and you can see the live performance here. I can see how many requests are there, how many when is the problem, when is the anomaly, and also I have here different indexes. So when it comes to access files, you can see that the URL information is all parsed here as in this part. So how did we do it? I'm sure you are all experts in this, so I will be quick about here. So in the LogStash, we took IP, year, date information, method, duration, and we also implement the custom URL because we needed to simplify that data. So what did we do in this pattern? These are the regex library. This is a regex library. So we didn't, in this case, we do not take the dynamic parameters after the last pipe here. So when it comes to the different cases, this is the application file. This is a log file, and this application has a huge, let me show, has huge stack traces because it is hosted in WebLogic, but it uses Glassfish jars inside. It uses many different dependencies, and so here is a huge stack trace. This was this was definitely the longest stack trace that I had seen until I started this project. So as you can see, it is hard to find the important information here. So actually, I had focused on this part. This information explains a lot. So I have tried to extract this information. So when it comes to LogStash app, it is this one. It takes log level, stack trace, and this one. It takes log level, stack trace, and then in the after error message, it takes the error message, and it also shows the that uses that stack trace. That's regex. So one of the interesting things that we did was to take the SQL information. So we could actually, our own .dba admin was somehow unable to get was unable to see the problematics SQLs. We had an Oracle database, and he couldn't get the anomalies. So actually, he logged this events. So as you can see, I was able to parse the SQL information here. Also, it gets the total duration and number of calls, minimum duration. And actually, the information was given as a cumulative in here. And we were able to see it as a cumulative information. So we can easily create a new bar to see. Please tell me if I am going too easy or too fast, because this is also my first experience in a Elastic community, Elastic meetup. You can easily take a SQL keywords. You can how you can use the sum of the number of calls, and you can easily see that this specific SQL needs to be cached, or there has to be done something about that. We have to do something about that. It was called 33,000 times in just last 15 minutes. So Elastic was able to show us the problems of our system. It was a deep wheel, and we couldn't see the end of it. But after that, we were able to see the all the inventory of the problems, and we were able to put them into a Jira, and we were able to manage them. It was a hard task for us, but it was possible. So, and this is the production environment. Do you have any questions about our production experience? Else I will start my own development. Do you have any questions on use case, production environments? I believe you don't. So let me show you. I built another ElasticSearch Kibana ELK stack into one of my servers here, and now I will show you the how to build such a system. To do that, I prepared a Java application. It makes some calculations, and it just makes random calculations. And it when I tell him to do, it should take 2 seconds. It sleeps 2 seconds. When I say it should sleep 5 seconds, and it sleeps 5 seconds. So I can differentiate the access log files here. So let me first show you the access file, log file here. This is the file, and you can see that I logged the URL endpoint IP information, and also the duration information here, and I had I parsed this information in a LogStash file. So I use this website. Actually, is ElasticSearch has also have a good debugger inside, but I like this one. So I take a few lines here, and also I put it here, and also when it comes, this is the actually the parsing information in LogStash, and when I run it, it also shows me where it is, how it parsed the data. So let me we can also write it as ourselves here, but it has a different, as you can see, it has the IP information here. I didn't not parse this one. I parsed the date information, words, methods, and the URI information here because I don't have a dynamic URL in my endpoint. And then I use the process time. I parsed in process time and commit time here, and I also got the bytes output, bytes of the response, size of the response. So when we actually make a request here, we can easily make a request and tell it to how long it should wait. So let me show you the code too. It's a simple Spring Boot application, and it also has a controller inside. It just takes an execution time information, and it all sleeps when however I want, and I also add a random sleep time to it. This is a simple code. So when I send the data to it, I can also make this a simple request. I can see it in LogStash in this part. Because I use FileBit, you can see that it is parsed here. Process time is 74 milliseconds, and there are some various information here and date information. When it comes to that, I used FileBit. We also used FileBit in our application. It actually made more sense to send the data into a simple log server. It made more sense to make a firewall like that. There are methods to in Prometheus and Grafana that to take the data from the resource, the source itself, but it actually makes more sense in our thinking to push the data from the local server, local app server, to the log server because it doesn't make a huge overhead in the server. Even it's actually make here specified the log file here and which files to send, and here are the Kibana URL and LogStash URL. If I had sent it directly to ElasticSearch, it would be stored as a document, full document. So I wouldn't be able to parse it. So I showed you the file widths, I showed you the LogStash, and here we can make some requests here, multiple requests here to make a fast information. It sends 100 requests. This is a fast request in this case, and we can see that they all arrived in our discover mode because FileWidth collects them, and LogStash sends them to the Elasticsearch. I can see the 100 requests here, and when it comes to the trend analyzing part, we can do it the following way. This was the original request that I had used in the in our production system. So in this part, I can use an aggregation here. I can select which part, which date to use, and also add which data to show it to. So in this scenario, I use the information in the past scenario. I can also use the past information like in a more specific way. Let us see the performance in the data, process time, URL. Was it URL? I couldn't remember because there are this the zero dog counts. Let me remember the LogStash configuration. URI param. So let me say URI param here. I couldn't see the reason why it failed to return yet, and it is because it has demo application here. Maybe I should extend the time here. Oh, it is 30. It is 30 March. Today. So you can see that it's actually groups the access log information, gives you the dog count, and it gives you the average count. It is 520 milliseconds, and In this scenario, I can easily, let me see if everyone is here. I can also look at the current time and it is a lot faster because I sent a request with a lot less delay. So let me send a slow data here. Actually, this will take a little bit of time. So actually, let me do it 5 seconds. Make it only 50 requests. We started in 1936. While it happens, I would also like to show you the our other application exception scenarios. So we in this presentation, you will remember that I've mentioned I actually parsed the data application log file, and I took the Oracle error, Java error, stack trace, and problematic parts, anomalies, and sent it to the according team. So it works as this way. We had in this scenario we used ElasticAlert, and we told it to we give it to the index pattern, also give the query string, and this is our DBA person, and all the events are sent to the DBA. There is only 1 minute of waiting if the same error occurs again and again and again. And also we also had used ElasticAlert's new term scenario, and we had used we had got our fields Oracle message and SQL message, because there are so much hundreds of exceptions in this scenario. And these are easily fixed by the DBA admins or developers, and we sent them in this way. This is the alert text, alert arguments, and this is the board. Everyone in this board. Let us see if our requests are complete. Let me see. It continues, but if we look, we will probably see that most of the requests are already in our log file. As you can see, the requests are coming here, and when we look at the discover, we will see the events are already here. It was also easy for us to actually filter those endpoints, well, like this, we were able to get any endpoints with taking more than 1 second, or any SQL taking more than 1 second. So we made visualizations here, and we were able to fix them easily. As you can see, there are a whole lot of problems we need to fix yet, but it is the better version of it right now. And when we come to the dev tool right now, we had started at 1936. You can see that this is an anomaly. It takes 5 seconds. We didn't have our machine learning applications here, so we actually made the request ourselves and compare it together. So how did we do it? So it is the code in the GitHub. It's already open here. So this is a simple Spring Boot application too. It just has some parameters here. It uses the spike height reference window. This means days, so it is 1 week. It goes past 1 week and 7 days. This is the minimum documents that the specific URL has to occur. It has to happen. If an endpoint is executed only 1 time, but it takes huge amount of time, we just ignore it. And this is the time threshold. This is the current time threshold. It takes current count threshold. You need to have 3 documents at least right now, and this is the current window time. This is minutes, 10 minutes. So, and this is the classical Spring SMTP configuration. And here you can see that we make 2 requests here. There are 2 requests here. It takes reference window, hour window, and minute window, and it prepares the request, HTML request here, REST requests. Actually, Spring has an easier way to do that, but I couldn't learn it yet, so I had to decide to make the HTTP request myself. And this is actually the same as the request right now. And when it is done, it makes the following results. Let me show you our example of alarm requests. For example, this request usually took just 80 milliseconds, but it takes 12 seconds right now. This endpoint has about 1 second average, but it takes 18 seconds right now. And there you can see the peaks over here. This is the reference window. This is the reference window, and this is the current window. How many requests are sent, and these are the configuration. I put it in the GitHub with the English version of email and configuration. And also, let me show you our alarm requests here too. That is one of the SQLs we had reached. And in this case, this Oracle problem in this stack trace, in this specific line, occurs new. So we actually, when we see it's a new one, we send an email and say something blew up. So there is a problem, and we don't send everything. We just send the related parts related to fixing. And this is another one. Let me show you another one specific to the board. It must be around here. I couldn't find one yet, but as you can see, there are hundreds of alarms. This is one of the requests. This is a specific board. This primary key exception happens only new recently. So we actually showed it, send it to the related board. This is what we did, and I can go into more details in the application now. Do you have questions for me? Can you redirect me?